Swayam Prabha. Digital India. Educated India.
Hello everyone, today I am going to deliver a lecture on friction stir welding process. This is a solid state welding process. Last class I have already discussed about different types of friction welding process. In that topics I have discussed partially actually about friction stir welding process. Today I will discuss in details about friction stir welding process. Okay. Now this is the content of today's lecture. Here I will cover first introduction, then type of friction stir welding process, then I will discuss about steps in FSW process, I will discuss what is the principle of friction stir welding process, then its different types of microstructural zone, then its process parameter, then setup, then I will discuss about what are the different types of joint we can make by using friction stir welding process. Then different categories of friction stir welding process, its brief description, and finally advantage, disadvantage and its applications. So you see this friction stir welding process, which I have already told you, it is a solid state welding process where the heat is generated by a rotating tool. This you should keep it in mind. So here the heat is generated by a rotating tool which makes contact generally with workpiece, and what happens due to these things there develop some frictional heating. Due to this frictional heating, what happens, the material becomes softened and joining is done. That is why what happens, as the heat is generated by friction and as the joining is taken place by some rotating tool where there is occurs some steering effect. That is why it is called friction stir welding process. Okay. Now this welding process is invented by TWI, that means the Welding Institute, which is in United Kingdom, that is UK, in 1991. This was initially used for butt and lap welding of metal and plastics, but nowadays it has some other application also that I will discuss in subsequent slide in details. But initial application was in butt and lap welding of metal and plastics. Now FSW is a process where generally there is no toxic fume or smoke is evolved during this process. That is why this process also is considered as green technology. This is a very important terminology in manufacturing industry, because what happens, once something is green technology, then its acceptance is more in any manufacturing industry, because what happens here, there is no polluted types of toxic fumes or smokes. Okay. The maximum temperature which is rises in this welding process is around 0.8 times of melting point temperature. That means around 80% of melting point temperature of parent materials. Okay. The process is energy efficient and it is environmentally friendly. Compared to other welding process, especially fusion welding process, it has lot of advantages, like in fusion welding process, whatever the fusion related defects or fusion related problem arise during joining process, that things we can eliminate in friction stir welding process. And another things we should keep it in mind, this process also can be automated. Okay. Now here I am just showing the types of friction stir welding process. Here you can observe there are different types of friction stir welding process. Here I am showing around 7 different friction stir welding process are there. So depending upon different types of parameter, it is categorized. So here I am just telling the name about these different types of categories of friction stir welding process. Like this friction stir welding process, here I am showing around 7 different categories of friction stir welding process are there, Among these, some of the type of friction stir welding process have some further number of variants, that also I will discuss here. So, you see this friction stir welding can be a rotary types of friction stir welding process, it can be self reacting types of friction stir welding process, it can be twin stir friction stir welding process, it can be under rotor friction stir welding process, and here you see I have written it can be stationary solder FSW, it is represented as FSW. FSW means F represent friction, S represent stir, and W represent welding. Here you can write this is the short form of friction stir welding. Okay. Now, another important friction stir welding process is hybrid friction stir welding process. You see there can be different categories of this hybrid friction stir welding process. Hybrid friction stir welding process means two different welding techniques or two different technology combined together and makes a new techniques that is generally called hybrid techniques. So, here as one of the technique is friction stir welding process, that is why it is called hybrid friction stir welding, because this friction stir welding process is hybrided with some other techniques. That other technique can be some other welding techniques or some other means, what I am telling understand, that is why it is called hybrid welding techniques. So, these hybrid welding techniques further categorized in different types of categories. Here I am showing around 5 different categories of popularly used hybrid friction stir welding process are. It can be arc assisted friction stir welding process, it can be laser assisted friction stir welding process, it can be ultrasonic assisted, it can be electrically assisted, and it can be induction assisted friction stir welding process. These are the very popular hybrid friction stir welding process, that is why I am showing these are the names. Okay. Now, I will discuss about this thing in subsequent slide in details. So, first of all I will discuss what are the steps in friction stir welding process. Here I have shown you 4 different steps generally involved in friction stir welding process that you can observe. So, here this first step, here what happens, first of all let these two plates, this is plate number 1 and this is plate number 2, these two plates we want to join together. So, first of all these two plates we have to rigidly clamped, this you should keep it in mind. So, this clamping should be such, that means this two plate during plunging or during welding times of welding of this rotating tool, this plate should not be displaced, this you should keep it in mind. That is why this clamp should be rigidly formed, or you can say it should be clamped firmly. Okay. So, first of all we have to clamp these two material pieces which we are going to join. After that a rotating tool, this is a rotating tool, this is called FSW tool, friction stir welding tool. Here I am showing a friction stir welding tool. Here you see this friction stir welding tool has a circular bigger diameter which is called solder. You see this is called tool solder, and another one is a smaller diameter or this smaller size compared which has lesser diameter or lesser size than this tool solder diameter, that is called probe or pin, or sometimes it is also called nib. This you should keep it in mind. So, nib can be different geometry. Nib can have different geometry, that means it can be cylindrical shape, it can be triangular shape, it can be square, it can be pentagon, depending upon the requirement what happens, it has different types of shape. It can be what it is called a threaded tool. So, that I will show you some of the very commonly used FSW tool in subsequent slides. So, here one thing you just keep it in mind, in the FSW tool there is a bigger diameter component and there is a smaller diameter component or a smaller size component. So, bigger diameter part is called tool solder, FSW tool solder, and a smaller size or a smaller diameter part is called tool pin or nib, which is generally inserted inside the workpiece. How it is, that also I will discuss here. So, in step 1 you can see here first of all a rotating tool, this is a rotating tool which first start rotation by using some rotating types of motor device. What happens, this motor device can be a what it is called vertical types of milling machine, or this can be some robotic arm. So, depending upon the requirement we can use different types of rotating arm. So, where generally this FSW tool is holded and this FSW tool is rotated. Okay. So, after rotation generally this tool is touch this workpiece, here you see this touch this workpiece. So, what happens during this touching of this workpiece, once this tool pin or tool nib tip touch the workpiece. So, and at that time generally there is a vertical force, you see vertical force is there, that is called generally plunging types of force. Plunging types of, because we are interested to plunge the pin through the workpiece thickness direction. Okay. So, first of all we have to touch this tool pin tip with this workpiece, and there is a force, normal force with on the top of this workpiece surface, and there is a contact, and as this tool is rotating, due to this what happens, this material here generally start what happens, rising its temperature. So, what happens once the temperature start rising, at that time generally what happens, due to this temperature rise, and if this temperature rise goes a sufficient value, at that time generally this material becomes softened. Okay. So, once this material becomes softened due to this rotation and frictional types of heating, then what happens, we use some downward movement of this FSW tool. Here you see the downward movement of this FSW tool. So, it is generally gradually it goes downward direction. It is a very slow process, you should keep it in slow process, in the sense during this plunging time, this time can vary from 5 to 30 seconds also. So, this plunging time is depends on what types of workpiece material we are using, what types of tool geometry we are using. Okay, because depending upon the material type and tool geometry, this plunging time is dependent. So, what happens once the material becomes soft enough, at that time generally what happens, we use a downward motion. So, during downward motion it gradually penetrates the thickness of the workpiece, and this tool solder surface, that means this solder surface contact with this workpiece surface. So, from touching of this workpiece with tool pin tip to touching of this what it is called solder surface with workpiece surface, this time is called plunging time. What I am telling, understand, this plunging time what I have told you, it is varying from different second to some minutes also it can be. It depends on what it is called material type and tool geometry type. This you should keep it in mind. So, you see that is why what happen in welding process, you can observe different types of phases. So, this is one phase, that means from touching of tool tip with workpiece to touching of tool solder surface with workpiece, this is called plunging phase. What it is called? Plunging phase. This I am writing here. Okay. At that time generally the material temperature is rising. What I am telling, understand. At the end of this plunging time, you should be sure that okay, the tool solder surface and workpiece should touch firmly. Once the solder surface touch this workpiece, after that what happens, we have to keep rotating this tool at that particular location for some times to further heating of that region to become materials more softer. At that time generally the temperature rise to its what working temperature. So, we have to keep the tool solder or we can say FSW tool in same location, that means in plunge location for some times to further heating of that region to a temperature, that temperature is called what working temperature. This you should keep it in mind. So, this time or this phase is called dwelling phase. What it is called? Dwelling phase. This you should keep it in mind. This is called dwelling phase. So, in dwelling phase what happens? Here just the tool contact surface with workpiece remain in same location, or that means in plunge location, and we generally rotate this tool during this contact time for particular time. Okay. This time generally it also depends the material type and tool shoulder size type. Generally this dwelling time or dwelling phase can vary from 5 second to around 20 second, 30 second like this. Okay, this you should keep it in mind. This is called dwelling phase. Dwelling phase means we have to keep the tool in same location for particular times to heat the workpiece material to a temperature that is called what? Working temperature. So, here the heat generated from frictional work is greatly depend on the relative increase of contact surface area as well as the relative speed of the rotating tool. This you should keep it in mind. Okay. Now, the third phase or you can say third stage, here I have shown here you can see at this third stage generally once this material is sufficiently heated, that means at a range of around 80% of melting point temperature, then we give a traverse speed, that means we generally start moving this FSW tool. Here I have shown this direction by using this blue arrow line. So, once we give this traverse motion, then what happens, this welding starts like this, and what happens, the material generally what happens due to rotational motion, this material generally fill the gap in this region. That material movement is taken place from what it is called advancing side to retarding side. After that it generally depositing back side, you can say. Due to this thing what happens, as there is occur some steering of this material due to this tool rotation effect, that means material is moving from advancing side to retarding side, that is why what happens, this is called friction stir welding process. So, what happens? So, to complete of this welding, like it start from this location and it goes till this location. So, to complete this welding process, it takes some time. This is called welding phase. So, this is called welding phase. This is called welding phase. This you should keep it in mind. Now, here once the weld length traversing is completed by this FSW tool. So, at the end we have to remove this tool from this workpiece, correct? We have to remove this tool from this workpiece. So, that is called exit or you can say retract phase. Retract phase, this you should keep it in mind. So, at this exit or retract phase, we generally remove the tool from this workpiece you see by using some vertical upward motion. So, at the end of FSW process, the rotating tool generally is retracted away from the workpiece material. So, it is leaving a cylindrical hole mark, you can observe it is leaving a cylindrical hole mark that generally once occupied by the tool pin. This you should keep it in mind. This cylindrical hole pin can be filled by using some filler material, or most of the cases in FSW process what happens, there is used a generally dummy material prior to the exit phase. This you should keep it in. That means what happens, instead of removing this FSW tool at the end of this workpiece material itself, in some cases generally we use a dummy material. Dummy material means another workpiece material which is connected with this weld plate end location. So, what happens, this tool we generally move towards this dummy material region. At that location on this tool come in dummy material zone, generally we remove the tool. Then what happens, this exit hole will be created in this dummy material. You should keep it in mind. It is called dummy material, or you can say some extra material. So, whatever the hole will be created if you remove the tool from this dummy material. So, this hole will be created in this dummy material zone, because we are removing the tool from the dummy material. Or if you remove this tool from this workpiece material, then whatever the hole will be there, in that hole we can use some filler material to fill that hole. This process generally consists the following step, like it consists flanging phase, dwelling phase, welding phase and exit or retarding phase. So, related to these phases I have discussed here in details. So, what I have discussed in previous slides, same thing, only here it is written, you can see. So, detail about this plunging phase I have written here. you can go through it, and what happens, this is dual phase and this is returning phase. Okay. Now, we will discuss what are the different types of microstructural zone observed in friction stir welding process. Here you can see that in friction stir welding process there can be 4 different types of microstructural zone observed. So, but in case of fusion welding process, there you can observe 3 different types of what is called microstructural zone. One is called, in fusion welding process, these 3 different microstructural zone is, one is called fusion zone, another one is called heat affected zone, and another one is called what is called base material zone. But in case of microstructural zone in friction stir welding process, there you can observe 4, or you can say, if we consider this base material zone, then we will have 5 different types of zone are there. Microstructural zone are there. In different books it has different types of category, but whatever the most popularly known, that categories of microstructural zone here I am showing. So, we can have 4 different microstructural zone in friction stir welding process. One is called stir zone, another one is called thermomechanically affected zone, another one is called heat affected zone, and another one is called flow arm zone. So, these are the different microstructural zone which I am showing in this right side figure, you can observe. So, here you see this stir zone, or you can say this stir zone is the zone which is generally correspond to the location of pin during welding. So, generally pin plunged, you can say. Okay. So, I am just drawing here, then it will be more clear to you. This is the tool solder. So, this is the tool pin. So, you see, so this tool pin zone, this is generally solder zone, and this is tool pin zone. So, near the tool pin zone, whatever the zone we get, that is called stir zone, or sometime it is called nugget zone, or sometime it is called dynamically recrystallized zone. This you should keep it in mind. So, dynamically recrystallized zone, or why it is called stir zone, because what happens in this location, nucleation and growth of material is occur during the deformation of the what is called material, because once this tool rotate and as the material soft enough in this location, so this material steering is taken place in this zone. Due to these things in this zone, generally materials nucleation as well as growth of this material is taken place. Okay. As this nucleation and growth of this zone taken place during dynamic deformation, that means during the deformation time, that is why it is called dynamically recrystallization zone. This you should keep it in mind. Okay. So, this zone is zone which location is generally correspond to the pin zone. This you should keep it in mind. Now, thermomechanically affected zone, thermomechanically affection, just around this you see, around this you see, this is the near this tool pin zone, here you can see this is called generally stir zone, this is called stir zone. Now, thermomechanically affected zone which is generally occurs on either side, you see this side as well as this side, either side of this nugget zone, either side of the nugget zone. In this zone, what happens, the material recrystallization is taken place due to what is called, due to deformation as well as what it is called plastic deformation of the material as well as due to heating effect. So, as the recrystallization in this zone taken place due to material deformation as well as heating effect, that is why it is called that means it is affected both thermally as well as some mechanical deformation means, that is why it is called thermomechanically affected zone. This you should keep it in mind. This zone is not available in what it is called fusion welding process, because in fusion welding process this types of zone is not available. There is only one zone, that is called heat affected zone, which is near to the fusion boundary. What I am telling under that, what I have already discussed in fusion welding process itself. Now, the third zone is called heat affected zone. This is generally common to wall welding process, with this heat affected zone which is just attached to this thermomechanically affected zone which I am showing here by HAZ, you can observe. So, in this zone generally this recrystallization, or you can say here generally this zone is subjected to only heating types of effect. By this generally this microstructural changes is occur. But in thermomechanical affected zone, here both heating as well as mechanical deformation process affect the microstructural changes. Okay. That is why this is that one is called thermomechanical affected zone, and this zone where only heat is the main concern to change the microstructure, that is called heat affected zone. So, another zone which is called flow arm zone, which you can observe, which is just upper surface of the weld. You can see here I have written here, you can see upper surface of the weld, and consists of material which is dragged by solder from retreating side of weld. This you should keep it in mind. Now, before going to details about this retreating, advancing, these types of terminology, you should know what is retreating side, what is called advancing side. Now, here you should keep it in mind. Let this is a FSW tool. This is a FSW tool. Okay. Now, let the rotation of the tool is like this, anti-clockwise direction. Okay. Let the rotation of the tool is anti-clockwise direction. Now, you see, now let the plate which we are welding, whose direction of welding is this, then you see, and if the tool is this is the tool. So, direction, this is the welding direction, what is called WD, I am writing welding direction, and let the tool is here rotating in anti-clockwise direction. Now, if this rotational, so this side, right side of this tool you can see, then if you draw the tangent of this tool's shoulder surface, you get generally just right side you get a motion which will be along the direction of welding direction. What I am telling, understand? Whereas, if we draw the tangent of this rotation in right side, we will get a motion in just opposite to this welding direction. So, if the direction of this tool and welding direction, that means WD direction, welding direction, that means movement of this tool direction, if two are similar, that is called advancing side. So, this if this tool is rotating anti-clockwise, here this right side is called advancing side, AS I am writing, and if this welding direction and tool rotational direction opposite to each other, that is called retreating direction. This you should RS I am writing, or you can say this is called retreating. That means flow arm zone is created due to the drag of material by solder from the retreating side of the weld. This tool generally once is rotated, this tool material generally it's moved from this advancing side to retreating side, which is generally further dragged from this retreating side to top surface, that is called flow arm zone. This you should keep it in mind. Okay. Now, these are the different zone of this friction stir welding process. So, these are the references which I have followed for making this lecture. Thank you.